Alright, so for this lesson today, we are going to talk about the surface area and the volume of a cell. Now cells need to carry out all life functions. They need to be able to transport matter efficiently. They also need to be able to reproduce, but we're not going to get into that today. What's important is that they need to be able to transport matter efficiently. So the way that a cell is able to transport matter efficiently is that it uses the cytoplasm as kind of a channel, or as a way of getting things from the outside into wherever it needs to get to inside the cell, or vice versa when it leaves the cell. One thing that's really important about the cell is that they're really small. They're small because that distance is now reduced. That something needs to go from outside the cell to, let's say, the nucleus, or vice versa. So because the cell is small, it's easier to get by. So if I had an example here, a cell here and a cell here. Let's say something came in outside on both of them, and it needed to get to the nucleus, right here. Well, it would have to go from here and then travel all the way down there, which is a lot further than if it just passes right here. So that's the whole point of cells being small, at least one of the major points. Another reason that they're small is because there's less matter needed. If you have a smaller cell, you just need less stuff, less of everything, just a smaller amount of stuff. Then finally, we have more cells, because if you have, let's say, one big cell, or you have 100 small cells that make up that one big cell, if you lose one of those small cells, it's not a real big deal for the organism, because there's so many other cells that take its place. But let's say you were a single cell organism. Well, if that cell dies, then the organism dies. So humans have millions and millions of cells, and those cells die. But because we have millions of cells, losing a couple cells here and there isn't a big deal. So those are some of the reasons why the cells are small. Now, what we look at in order to get our surface area and volume, and why we care about that, is because if you have a really large surface area, you have more entrances and exits for things to get in and out of the cell. So if I have a little example down here, let's say you're going to Disneyland. And Disneyland, you have these 3 gates. So we're just going to look at this. Let's call that 100 meters of entrance. And Disneyland wants to get people in as fast and efficiently as possible. So instead of just leaving it as these 3 entrances, what they could do is take their gates and make them like this. Now we're still in that same 100 meter width, but now you can put gates all over the place. You can put a gate here, you can put a gate here, you can put a gate here, gate here, gate here, maybe a gate here, and a gate here. And that allows 1, 2, 3, 4, 5, 6, 7 gates compared to 3 gates in that same 100 meter distance. Now people can get in from all over. That's the same with cells. If you have more entrances and exits for the cell, then things can get in and out of it a lot easier. Gives it more area to diffuse. Then a small volume obviously means we have less matter. So the more entrances you have for a smaller cell, the better. Therefore, a large surface area to volume ratio indicates that that cell is more efficient and more effective at surviving and at exchanging matter and just doing all that life functions include. Let's look at calculating the surface area to volume ratios. First, you're going to calculate surface area. So of a cube or a sphere or whatever you're dealing with, then you're going to calculate the volume and then just divide the two. It's that simple. So let's try one. Let's determine the surface area to volume ratio of a cube with 4 centimeter sides. So that's a cube with 4 centimeter sides. Not the best drawing, but that's okay. And then we'll do a cube with 1 centimeter sides. So first, 4 centimeters, let's find the surface area. Now the surface area of a cube means this surface, and this surface, and this surface, and then the surfaces on the other side that we can't see. So the surface area for a cube is equal to base times width, so let's call that 4 times 4 for this surface area here, times 2, because there's another one on the bottom that we can't really see. Then we're going to add your base times height, which is going to be this 4 centimeters times this 4 centimeters to give us this square here, times 2, because again there's one over this side that we can't see. And then you add your width times height. So that was this 4 centimeters times this 4 centimeters to give us our final side. And of course, the side over here. So we multiply that by 2 as well. Now in this case, our values are going to be 4 times 4 times 2. You could just do base times height times width, but we're going to do it step by step. Base times width, or sorry, base times width times 8. We're going to do base times width times 2 though. 4 times 4 times 2 plus 4 times 4 times 2 plus 4 times 4 times 2 gives us 96 centimeters squared. So that's our surface area for the first cube. Now let's look at our volume. The volume for a cube is base times height times width, which in our case is super easy. 4 times 4 times 4 equals 64 centimeters cubed. Now we're just going to divide surface area by volume. So we have 96 divided by 64 gives us 1.5 to 1. So that is our surface area to volume ratio for the 4 centimeters. I'm actually going to move this over here and get rid of all this so I can redo the next one. Okay, for the next one, we have a little bit better, 1 centimeter sides. Surface area for any rectangular prism is, so like a cube, base times height times 2 plus base times width times 2 plus width times height times 2, which is just a bunch of 1s being multiplied. 1 times 1 times 2 plus 1 times 1 times 2 plus 1 times 1 times 2, which gives us 6 centimeters squared. Now our volume is again base times height times width, or 1 times 1 times 1, which is just 1. Then our surface area to volume is going to be 6 divided by 1, or 6 to 1. For which one would make a more efficient cell? Well, the one with the higher surface area to volume ratio is going to be more efficient. So therefore, this 1 centimeter cube would be more efficient than a 6 centimeter cube. And that just makes sense because there's a much smaller cell. Alright, But what if these aren't cubes? What if they're different shapes, like this and this? This one's a cube, but this one's not a cube. This one has a lot larger sides than some of these sides, but this one's got a really long edge. Now, when you have a bigger object, you have more surface area. But when you have a bigger object, you also have more volume. So we have to use the math to figure out which one would be more efficient. So let's take a look. Let's find the surface area first for this one. It's going to be base times height times 2 plus base times width times 2 plus height times width times 2. I'm going to use this as my base, so 12 times my height of 6 times 2 plus my base of 12 times my width of 1 times 2 plus my height of 6 times my width of 1 times 2. When you add that together, you get 180 centimeters squared. Now let's look at our volume, which is base times height times width, which is 12 times 6 times 1, or 72 centimeters cubed. My surface area to volume ratio is then going to be 180 divided by 72 for 2.5 to 1. It's just 2.5 because it's 2.5 surface area to 1 unit of volume. It's just a ratio that we use. We don't use units for this. We just care about that 2.5 to 1 ratio. Basically, for every 1 centimeter cubed of volume, we have 2.5 centimeters squared of surface area. Now for the cube, we should know how to do this one. Surface area is going to be, I'm going to use the short one, base times height times 6, because base times height is the same all around, which would equal 6 times 6 times 6, or 216 centimeters squared. Volume is actually the same, 6 times 6 times 6, because it's base times height times width, 216 centimeters cubed. Just coincidence there. Surface area to volume is very easy to calculate in this one because it's 216 divided by 216 gives me 1 to 1. So for every 1 centimeter cubed of volume, we have 1 centimeter squared of surface area. Now this guy turns out to be the more efficient cell. And that's not just because of the shape, rather the dimensions of the shape. If we had a much maybe larger height to this one, we might have more or a less efficient cell. But yeah, that's the surface area to volume ratio calculations. There's not going to be too much on this, but it's good for you when you move on to Bio 20 and 30. That's all for now. Have a great day.